What's up everyone, welcome back. Patrick here. Moving on to the next question on the rate of change unit test. So we're told the value of a cell phone is modeled by the function v of t equals 162, 0.64 to the power of t. So notice it's an exponential function where v of t is in dollars and t is the number of years after purchase. And we have to find in part A the average rate of change from 2 to 4 years, in part B the instantaneous rate of change when the phone is 2 years old, and then part C we have to find the max and min values of the phone during the first 5 years. Okay, so starting off with part A, this one is going to be pretty simple. Average rate of change from 2 to 4 years. So what we could do is find the value of the phone during the 4th year, subtract the value of the phone during the 2nd year over the difference in the independent variables, which is the time in this case. And when you plug in these values, so plugging in 4 and 2 into the function for t, you get these corresponding values of the cell phone, take the difference divided by 2, and we get an average rate of change of negative 19.59. And so what units are these? Well, notice that the dependent variable in this case is the value of the phone, which is in dollars. And so on average, it is decreasing in value because we got a negative here, which makes sense in the real world. It's decreasing by $19.59 per year on average from 2 to 4 years, right? So these are the proper units that you're using for the rate of change in this particular word problem. Moving on to part B, we have to find the instantaneous rate of change when the phone is 2 years old. So again, we could do different methods. I'm probably going to do the centered interval method. So just to show it on a number line. So we're trying to find the instantaneous rate of change at 2. So if you remember, for the centered interval method, we pick an x value, or in this case a t value, very close to the left, so let's say 1.99, and then to the right, so 2.01. And then what happens is we're finding the average rate of change between these two very close points right here, right, with 2 being in the center. And because the points are very close, that's going to give us a good approximation for the instantaneous rate of change. You could also use the preceding and following interval method. So if you remember what that is finding the average rate of change between 1.99 and 2, and then 2.01 and 2, and then finding the average of those that you get, adding them up, dividing by 2. So that way has a little bit more calculations. What's nice about the centered interval method is that it's only one calculation, right? So we're basically going to do v of 2.01 minus v of 1.99 divided by 2.01 minus 1.99, like that. And so when you plug these in, 2.01, 1.99 into the function for t, you get these corresponding values here. Don't round too much here. Usually I round to 3 to 5 decimal places, because when you're dividing it by 0.02, you're going to be moving the decimal place a lot. So the decimal places definitely matter. And when you end up doing this, you end up getting approximately negative 29.62, right? So this is negative $29.62 per year. That's the instantaneous rate of change, or that's how much the value of the phone is decreasing per year at 2 years, right? The instantaneous rate of change at that single point of 2 years. And then part C, what is the max and min values of the phone during the first 5 years? Well, if you remember the properties of an exponential function, just in general, right? An exponential function is always either increasing or always decreasing, right? And it could also be in this kind. It could be decreasing like that, could be increasing like that, different shapes. But nevertheless, it's always increasing or always decreasing. And so if you think about it, for an exponential function, the max and min values over a specific interval, so they're saying when t is between 0 and 5, the max and min values, they're always going to be on the ends of the interval. Okay, and then if we were to take this and just quickly do a rough graph, so if we plug in a t value of 0 here, 0.64 to the power of 0 is 1 times 162, so the value of the phone is starting at 162, and then what's happening is that it is decreasing in value because you keep multiplying by 0.64 each value, right? So it's always decreasing. And so up until the 5th year, right here, so if we plug in 5 into this function, you would get a value of 17.39 approximately, right? And so the maximum value of the phone on this interval between 0 and 5 is going to be at the beginning of the interval. So the max value is going to be $162, and then the minimum value, the lowest Y value on this interval, is going to be at the end of the interval at the 5-year mark, $17.39, right? Because it's always decreasing the whole time. There's no like turning point or anything like that, like there is with a quadratic, where a quadratic would have like a minimum here, or if it was opening downwards, there would be a maximum there, right? So there's no turning point, it's just always decreasing. So the maximum value is at the beginning of the interval, minimum value is at the end. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.